Let me know if you can hear me. If you can hear me, please type something in the chat so I know I'm there. Okay, sorry about that. Started a bit awkward. It's my first live stream, and I did things a bit not the best way I should. I'll show here a small presentation that I prepared. Now, what we'll talk about is about the Gen 3 platform, engineering secrets. I did an engineering analysis of what I expect Tesla to have in their Gen 3 platform. And I just checked what their goals should be and what I expect them to, how I expect them to achieve that. And the results were pretty surprising, because what I saw is that they can actually reach much, much lower production costs and production time. So let's just start. Oh, wow, this is really bad. Sorry about that. I'll try to, I think I'll have to just hide myself and just maybe prepare an avatar. One moment, please. I just fixed things. This worked before. One moment. Okay, sorry about that, but I think this will be a bit safer. I have to maintain my anonymity. I'll have to hide later on the picture. So sorry about that, and let's start rolling. Let's start with the presentation. So let's just go and share the screen for a moment. Okay, we'll talk about the Gen 3 platform engineering secrets, what I saw in the technology. Now, first, let's start with a few disclaimers. This is not an investment advice. Some of the things I think will happen, but many of them will not happen. They're just speculations. So don't take it as investment advice. Do your own research and think what you think is right and what won't happen. I'm very long Tesla. I'm highly invested in it, including a few leaps. I'm not pumping on stock, of course. I believe in everything I say, but I show you just the technology and you understand what you want. The live stream here, as you can see, is a last-minute decision. I didn't have time to prepare it. So there is a 20-second delay between what I'm saying and what you're hearing. It'll be a bit awkward to operate this, but I think we'll manage. And most importantly is yada, yada, yada. Let's start with the content, because that's what's important. So let's go on. Let's start with Tesla's mission, which is to accelerate the world's transition to sustainable energy. And what this means is everything I'll show starts from this mission. This is what they're trying to do. This is what master plan number 3 is about, or 3 is about. So let's continue from there. From this mission, if we focus on automobiles, I think that their strategy will have 3 parts. Because every EV that is sold replaces an ICE car, but the pace of replacing them is very, very small right now. It takes decades. So they want to make insanely gigantic, massive amounts of cars. And this will enable them to have a lot of supply for the market and give the car and a lot of supply to sell. But the thing is, once they have the supply, they also need people to be able to afford them, because right now the cars even though the Model 3 is currently cheaper than the average car in the United States, the average car in the United States is not the average car in the world, because let's say in the United States, we'll look at the Camry class. In the world, it will be the Corolla class or even the Yaris, which are much smaller cars. So what this means is we need to make smaller cars. They also need to make them more affordable. Now, I know there will be the prices are going down all the time. So what will happen is we will see that the Model 3 price will go and decline with time, but I'm not counting on that part, because if they ramp fast enough, what this means is that they will always be able, if they make the Model 3 very, very cheap, if they make an even smaller car with the same technology, it'll be even cheaper, just because the amount of materials, the cost of materials will be lower, because smaller car needs lower materials. It's smaller, it's weighs less, and so on. So they need to make an affordable car, and they need to make these cars desirable, because if they produce the cars and people can afford them, but they're not desirable, then many people will not want them. So let's go on and see what goes from this. From insanely gigantic numbers of cars, they want to significantly shorten the production time. So at a certain amount of time, they can make many, many more cars. That's one thing. Another thing is they want to make the cars affordable. So what this means is they need to shorten to lower the production costs, and do that while still maintaining margin. Because if they're losing money on each car or not very profitable, this will prevent them from investing even more and progressing even more. So they need to maintain margins while lowering production costs. And the third thing, to make them desirable, they want to improve the product, not to decontent it. And these are the goals. Let's see now how they will achieve them. And I saw a mix of strategies. Now, what we'll see during this live stream is we'll go through these strategies, and we'll see for each one of them for each of these strategies, we'll see a few examples of technologies that enable them to achieve this. And I drew these circles as overlapping, because many of the things they will do will be, many of the technologies we'll see will affect many of these strategies. There will be things that they will affect the dry tech factory and virtualized mechanical connections and so on. So we'll just go through it and see the things. Sorry. Let's start with larger and then smaller. First of all, what I just want to say is decontenting is not a major strategy. Now, in this, I'm a bit I'm putting myself on a limb. Why? Because previously I saw videos by Monroe and Associates, both by Sandy and by Corey. And both of them said that they talked about decontenting the cars. And both of them said it would be a very bad idea, and they don't think, this is why they think Tesla will not make small cars, because nobody wants to buy a very cheap car and so on. I agree that people don't want to buy a very cheap, not inexpensive, but cheap car, and it will ruin Tesla's name and brand name. But Tesla showed us before that they do not decontent significantly. I mean, the Model 3 has it's lower spec than the Model S, of course, and so on. So it's a bit decontented, but it's not really decontented. It's not without the sensors and without the, it has everything the Model S, for example, has. It's just a bit lower, but it's still a luxury car. So what I see is that the small car will also be, it'll be still 30% profitable like the larger ones. but it will also be, it'll still be a Tesla. With everything we know the Teslas have, it'll be still be luxurious and so on, but they will find a way to make it less expensive. And we'll see these ways in a moment. So, okay, let's start with larger and then smaller, the first strategy. Now, this strategy basically says that they will start with the Highland Model 3, which I call the Tesla Pi. If you haven't seen my videos about my Highland videos, they explain why I call them that. So the first car will be the Tesla Pi, and only after they do that, they will apply these lessons to a larger volume but lower price car of the Model 2, which I call the Tesla Tau. Sorry, one moment, please. Okay. So first of all, the Model 3, the Tesla Pi, it will be the replacement of the current Model 3. It will be every bit as luxurious, probably even more. It'll have everything the current model does, but it'll be much, much less expensive to produce. Now, some of the things we know already, which will be all the things we see in the Model Y, such as the front and rear giga castings and the structural battery pack and so on. But what I believe is that the Highland Model 3, the Tesla Pi, will be basically the prototype for the Model 2. It'll be on the new platform. The third-gen platform will be for the Model 3 and for the Model 2, and later on for the robotaxi and for Model Y and so on. All cars will eventually move to that platform or something like that. So they'll start with Model 3, where they have more margins, a higher price on which they can make mistakes and so on and learn things. And they will also, they also produce it at a much lower pace than the Model 2 is expected to be. The Model 2, the Tesla Tau, will just flood the market. So basically, they have a learning curve on the Model 3, and then they'll go to the Model 2. So Tesla Pi will be first. And as I said in my previous video, which is just a wild guess, all these names are wild guesses, but if Tesla Pi is the name, if they call it the Pi, then they will probably start selling it on March 14th, which is Pi Day. So that's just a guess. Okay, and Model 2, if I have to guess, I don't know when would they'll make it. If I have to guess, they will launch it on Tau Day, which is on June 28th, but probably not this year, maybe next year or 1 year after that, I don't know. It's basically how fast they can ramp up. Now, as I said in my previous video, I do expect them to ramp up very, very quickly with the Model Pi. They already prepared for it. Right now, something that I didn't show in these videos, I've heard that they hid the giga casting and the giga presses in Austin and in Berlin and possibly other places too. So they're hiding it. They're not allowing drone flyovers right now. So they're doing something. And what I believe they're doing is that they are starting to prepare the new castings for the upper body. So we'll go through that later on. So the strategy, I saw that they start larger and then go smaller. And the reason for smaller is that the smaller the car, the less materials it has, so it costs less, not decontenting. Okay, so we already discussed this. One reason why Tau is not needed, the Tesla Tau is not needed, is because prices will decline eventually with time. They're going down right slow, and the more cars that they produce and the more batteries they produce, the prices will go down. So Model 3 right now, it's about the average price of the car sold in America. The prices will go down and down, lower and lower, but as low as they can get, Model 2, the Tesla Tau, will be even cheaper, less expensive to produce, and so cheaper to sell. And their goal in this will not be to just replace new cars, but also to replace older cars, used cars. So people who have older ICE cars will just replace them with a new or relatively new Tesla Taos. But as I said, it is needed because of it's smaller, so it needs less materials, a little bit cheaper. Okay. The next strategy I want to talk about is dry factory. Now, one of the things that really is a problem with factories, one of the largest hurdles with factories is liquids. By liquids, I mean with ICE cars, it's the coolant and the refrigerant coolant and the engine oil and the power brakes fluid and power steering fluid and so on and so on. And all these fluids are very hard to handle and they're a mess to handle. And there are lots of processes with handling them and you have to supply them and so on. So they want what I call dry factory is just remove almost all the fluids from the car and from its production. And I started with the gear castings because it doesn't seem logical at first, because if you think about giga castings, you don't see any fluids here. There are no brake fluid and so on in the chassis. But the reason is that once you when you build a car from parts and you attach the parts one to the other, what happens is you need to put sealant between them. And the sealant is some kind of yellow goo or green goo and whatever. It's a mess to put it. It's really, I've heard several, if you talk to people who work in car factories, the number one thing they'll tell you they want to get rid of is that sealant. And when you move to jig castings, you have less parts to attach to each other and you have less parts to seal between them. So what you had before, let's say in the early Model 3, where the entire rear section, the wheel arches and so on, were made from lots and lots of small parts. Then you had to solder them together and to glue and then once you attach everything together, you have to seal everything with a sealant, so there will be no leaks and so on. And once you go to giga castings, you remove all that. Now, what I see with the giga castings is that there will be the front giga casting, the rear giga casting, just like in the Model Y. Central structural battery pack. We'll talk about the battery pack later on. And above all that, the entire upper area will also be giga cast, a large giga casting, one, not two. And all of these will be attached together. Now, there are some advantages to making everything in one part, but also disadvantages. And the advantages are not very large. I think they will keep this, as I said before. I don't think they will even make the floor pan, the lower chassis, as one piece. They will just keep it as three pieces as we described, the front and rear giga castings and the battery pack in between. So giga castings have the dry factory. Let's go on. Another thing is brakes. I don't know if you saw my Cybertruck videos, but one of the things I predicted that Cybertruck will have will be Sensify brakes. Sensify brakes are innovation by a company called Brembo, which is currently Tesla's largest brake supplier. By the way, letting me know if you're hearing me okay. So I just want to check that I'm in open loop right now. So if you hear me okay, if it's clear enough, then just let me know. I see, by the way, in the chat here for a moment that someone, TF Raja 1 said about the Osborne effect. I don't think they will have an Osborne effect right now because they will launch the car very shortly after Investors Day. As I said before, I expect them to show the Tesla Pi on Investor Day and start deliveries about 2 weeks later. It's a wild guess, of course, but I won't be surprised if that will happen. Okay, let's go on. So Brembo is currently Tesla's largest brake supplier, and they came up with a system that I think Tesla helped them develop it. I'm not sure, I don't know, but I assume it. And this system, they call it Sensify. Basically, it's brake by wire. The brakes are, they're all computerized. What you do is you just break the pedals here. And from that moment on, most of the things are just computerized. Now, they have 2 versions of it. One of them attaches to hydraulic lines and pumps and so on, and it does have hydraulic brakes, right, like current models, but just with very shorter hydraulic passes. I don't see Tesla actually using this. I think Tesla will use the solution we see here in the back. I don't know if you can see with the cursor, but the solution we see in the back, which is just by wire. What you have here from the brakes wire, the brake pedal basically has a potentiometer, but then potentiometer which goes to a computer box, and from there everything is just computerized. The signals are sent to basically to motors, the actuators that actuate the brake calipers on each wheel. So you'll have this on all 4 wheels. In this picture, the front is hydraulic, but what I see Tesla using is all electromechanical calipers. And what this means is basically that they don't need to have any brake fluids and brake pumps and so on. Let me just check for a moment. I think I have a picture here of that. One moment. Okay, let's go on. So it saves a lot of piping. All of the lines here, basically in a regular car, what you see here as, one moment, I'll just show it. I think it'll be best to just show a diagram that I have. Oh, I have it later on in the, one moment, let me just move to the correct slide. One moment. Okay, the picture I have is for the steering, so let's just go on. Basically, what you have here, we usually have these pumps, and you have a vacuum hose going to the engine to get a vacuum to produce vacuum for that, and lots of lines and hoses carrying the fluid with pressure. I've gotten comments for the Cybertruck video that said that the by-wire brakes won't be very safe, but that's not true, because basically it's even safer, more reliable than hydraulic brakes, because you don't have all these hydraulic hoses and so on. So it's actually safer. Okay. Next, let's continue with the slideshow. After the brakes, another thing is also the steering. In a regular car, what you see here is with the steering, you have a power steering, you have a hydraulic pump and control valves and all these hoses carrying the fluid from one place to another, and you have the pistons and so on. And all of these will be gone. You don't need any hydraulics once you use by-wire steering, steer-by-wire. I showed this also in the Cybertruck video. So basically what you have from the steering wheel will just be, again, just be a controller with a potentiometer and so on. It'll go to a computer, and the computer will send signals to motors, actuators on the wheels, and which will turn the wheels, steer them. So you don't need all these lines, you don't need all the hydraulic fluid, and you don't have to fill it. By the way, filling all this fluid is really a huge problem in factories, because you don't just need to fill it, you need to top it up. And then you need to bleed the brakes, and you need to bleed the hydraulic system and so on, which means to remove all the air bubbles from it and so on. So it's really a nasty process. It takes lots of time. And Tesla really, what they want to do here is A, remove costs, but B, mostly remove time, production time. They want to make it much, much faster. So removing all these hydraulics is much, much faster. Another thing with the drive factory cells, and this, I think you know, basically Tesla, when they produced the 4680s, I don't know what their current status is, but eventually what they have is the dry battery electrode. I understood from the limiting factor that right now they have it only in the cathode, I think, but they'll have it on both sides later on, I guess. But basically the dry battery electrode, also it removes all the solvents and the drying process and so on. So it speeds things up, it's much faster, it's more environmentally friendly and so on, introduces costs and so on, extends life. So basically, it's both cost reduction and time reduction, and it saves factory space. So that's one more thing. So I think we covered right now the dry factory. What I showed here are just examples of things that can be done, removing the hydraulic brakes and the hydraulic steering and the power steering and the dry battery electrode and the sealant because of the combined part and so on. These are just examples. What I did here is in a very, very short time. I'm sure Tesla, which are much more professional than I am, and it's their job, and they did it for a long time. And then they have lots and lots and lots of other things to show. But just the things I showed here, they remove a huge amount of cost and time from building the car. Okay, so I talked about the dry factory, and I said that the strategies will combine. We see that things that they do for one strategy will also help with others. Now, when I talk about virtualizing the mechanical connections, what I mean is, one moment. Basically, the cars have lots of mechanical connections. And each of these connections, you have to assemble it, you need to, it's linkages and supports, and you have to fit everything and assemble things, and a lot of work. So if we want, and we'll talk about brakes and steering and wiring. So if we talked about brakes and we go to the Sensify system that we saw before, then what you have from this, you have just the pedals and lines wires going to the computers and wires going to the actuators on each wheel. Where in a regular brake system, I think I should show this. It's really telling. One moment. Sorry about that. As I said, I didn't have time to prepare a lot for this. It's my first live stream, and I just had a last-minute decision to make it because I didn't want battery day, Investor Day to pass, and they have lots of technologies to show. So it's a last minute decision. Sorry about all these hiccups. My next live stream, when I do it, will be just about flawless. Sorry about that. Okay. A moment. I want to share something else. I'll just show it. Okay, basically what we see here is that we see here power steering, and we can see how many connections we have here. And basically we don't even see the entire picture, because let's start from the steering wheel, just the beginning. From the wheel, there is this steering rod that goes down towards the entire system. And so you have to attach the wheel to the rod. You have to make the rod collapsible. So in case of emergency, in case of an accident, it doesn't go and pierce the driver's body. And so on, so you have to make it collapsible. And you have to hold the rod in these brackets and so on, let it turn and so on. It has to go through the firewall of the car till it reaches the steering rack and so on. The steering rack itself, you see here all these hydraulic systems and so on, and these linkages and so on. And there are lots and lots of bits and pieces to, first of all, manufacture, and then to connect and assemble, and they have to be in a very precise way so everything works as required. And what Tesla will do instead of this will be just very, very simple. One moment. They'll just for the steering, just like for the brakes, they will just have a steering wheel will just be a controller that they can just attach it anywhere they want. For a right-hand car, they will put it on the right side of the car. For a left-hand drive car, they'll put it on the left side. Just need to connect it. Basically, they even had they wanted to have certification to have these controllers on cell phones and so on. So something that is very virtual and so on. But basically, you don't need to connect it to the car. There's no mechanical connection. You just control what the controller does. It's just like a joystick or anything. You turn it and it sends signals which go to the computer, and then from there to controllers on each part of the car. And you don't have all these mechanical pieces between them. Just have this game controller and wires going around. So it's much, much easier. Okay, so brakes and steering, they help also to remove all the mechanical connections. The mechanical connections just become virtual. And about these mechanical connectors, one of the things is the wiring. We'll talk about wiring later on. We'll discuss it later on. Okay. Now, the next thing I want to talk about, this next strategy is, you all know the saying that the best process is no process, and the best part is no part. So okay. Basically, when you make cars, there's a good example that there was a video by Dr. Know-It-All, where he invited his friend, Dr. Scott Walker, who's a robotics engineer. and they discussed manufacturing cars. And Scott described how he talked about something that was also in today in Stephen Mark Ryan's video about complexity and so on. But basically he said how when you make the seats, you have various stages, and different cars have different seats, or sorry, even the same car, different trim levels have different seats, more plush seats or lower complexity seats and so on. And a limiting factor in the speed that the production line flows is how fast the slowest station can move. And what happens is that you have these people produce the car, each of them is in their station. And when they get like a very simple seat, they can just make it very quickly what they need to do. When they need get a more complicated seat, it takes them more time. So the speed is ratioed by, so it will enable the process to go forward according to the lowest time, but you try not to make the slowest seats or the slowest parts go consecutively. You try to spread it. More importantly is, let's talk about the process of making seats. The seat has many parts in it. You have the foam, and if there is, most cars have heating, and I see even the Model 2 have seat heatings and so on. So we have a heating mat inside, wires, and they have maybe it also has a air conditioning inside in the upper trim seats and so on. But all seats currently are made by foam, and they are covered with a seating material. And the thing about the seating material is that a person actually has to work and stretch that material and cover it over the seat. And if you watch the video by Dr. Know-It-All, I'll leave the link to it below. That's a really nice part how you can see how Scott shows the person just making. It's really hard task. It's really hard task to just push it and pull it and cover the seat and so on. A lot of work, a lot of manual labor in that part. But Tesla says the best process is no process. So what they will do instead is just go and show it. Okay, Tesla had a patent for what they call skin foam, which means when they make the seat, they don't need to start stretching the foam and the cover over the seating material over the foam itself, but rather while they assemble it, they just make it bond together while in the process of making it. It's much less labor intensive, much quicker. It's done in the place that they make. It's call it skin foam architecture for seating. So basically, it's a much simpler process. It takes less time, less labor, and faster. And I see this happening with the Model 2, of course, but possibly also with the Model 3, the Model Pi. I don't know how high quality, how plush it is. So that's why I'm putting this asterisk so that maybe it won't be in the Model Pi and so on. But with the Model 2, the Model Tau, which they wanted to be a cheaper car and just lowering the price and making everything much faster, I'm pretty sure they'll have it. My bet is that also in the Model Pi, the Model 3. So the sealing material here, the skin's foam, more molded on upholstery. So it's something new. Now, there's also something else they did with seats, which I don't know if they'll show, which will be, I don't think that will be in the Model 2. I don't know, basically, but they also have another patent on a way to heat and cool the seats, in which basically they have your channels with fluid going through them in the foam. And this fluid can be either hot or cold. And if it's hot, it can heat the seat. If it's cold and you blow air through it, then it cools the seat. And it is actually cheaper to do than the regular method. Until now, they didn't do it. I think that probably with the new platform, it's a time to do it. There is a chance they'll do it. And if they do it, and this phrase is interesting, there's a good chance that this system will be connected to the octovalve. So the thermal management, the central thermal management, there's a chance that it will also drive the heating and cooling of the seats. As I said, everything here is speculations. If you ask me about the probability of this one happening, it's pretty low. Basically, I don't know. I'm not ruling it out, but there's a good chance that they will do it. I don't know. But potentially this can reduce the price of the cost of manufacturing the heating and cooling of the seat. Okay, let's go on. Okay. Hi, Scott. I just saw your note here in the chat. So, hi, I'm glad to see you here. And basically, I really like that video. Very good. Okay, let's go on. Okay, we discussed these seats. Let's go back to the best processes, no process, and so on. We talked about the seats. The best process and parts also refers to the wiring. And in this case, I'm pretty sure you all know what I'll show here is the patent that Tesla has for wiring. Okay, cars have lots of wires in them, miles of wires. Tesla's cars are relatively efficient in that part. So they have much shorter wiring than in other cars. But Tesla also has a patent of reducing the wiring by basically using buses, connection buses and so on. So a very small, very limited amount of wiring will serve the entire car. I don't know, some of you probably remember that when Sandy Monroe checked, I think it was the plate Model S, he was disappointed to see that the wiring was still the old type, which you mean normal wiring, not the new type as we see here in this patent. But basically, that's because they still used an old platform. And now, because I see Model Pi and Model Tau using a new platform, now is the time to use it. I really believe that they will use the new wiring architecture in the car. And all this saves a lot of time. When you assemble the wiring, some of you probably saw it in Corey discussed this both with Farzad and with Brighter with Herbert recently. He discussed how all these wiring harnesses, they not only weigh a lot, which is also, if you remove the weight, it helps efficiency, and with an EV, it's very important. But also, it's a hassle to produce it. If you have various variants of the car, which means one version is a different, one trim level is different from the other. They have different wiring looms or different connectors in them. And you have to make sure that the wires are not pinched as you pass them and connect them throughout the car. And it's really hassle. And this is much, much simpler. So it saves a lot of assembly time. It saves money. Even the cost of the wiring itself, the copper and so on, it reduces it. It's also another added benefit. So it's all about reducing time and cost of producing the car. And just the things I saw here, which are just the tip of the iceberg of what Tesla can do, they already reduced the price of the car by a lot. So I see the price reductions as huge. Now, I said that the best wires are no wires, and yet I showed this architecture which still has wires. And so let's go one step further, and we'll talk about wireless communications. I think so. I checked that there is one. I'm not sure this is the best example. One moment. Okay, basically there are ways to connect have an intra-vehicle, which means inside the vehicle, a communication system which is wireless. So basically, this is just one example from one paper I read that discusses both the intra-vehicle, which means inside the vehicle itself, as opposed to intra-vehicle, which means to notify other vehicles of what's happening. So, sorry. Inside the car, as you can see, some of the system can be wired, and some of it can be wireless. There are different protocols that can be used. These are just some of them. I saw also other protocols which can be used. But basically, it is safe. There will be redundancy, and it will be cheaper than just using wires. And one area which this can really be also important is inside the battery pack. So if you want each of the cells to inform the battery management system of its state of charge and temperature and so on, so you need lots and lots of sensors and connectors and so on. And if you do everything wireless, it saves a lot of money. So basically, that's it. It saves both weight and cost, and it will still be reliable and foolproof and so on. There's no need to worry about not having the wire, so suddenly the brakes or something else won't work. And I do see, basically, at least in the next few years, that the safety critical systems will still remain wired, even though it doesn't have to be, just for doing it gradually, they'll still be wired. Okay, let's continue. Okay, another thing that I want to discuss is contingency, which means eliminating showstoppers, and something that Tesla already does. We saw right now that they wanted the Austin and Berlin cars to be 4680 with the structural pack and so on. But because 4680 production took time to ramp up, it's still not ramped up as fast as they want to. So they let the cars also accept regular packs and so on. So first of all, which means by regular 2170 cars, cells, or LFP batteries, and so on. Now, first of all, I want to make one distinction that I discussed it already in some of my videos, but not everyone knows, is basically all the battery packs I see in the new cars will be structural. And the same goes also for the Berlin and Austin Model Ys. All the packs, they are structural. Even the 2170 packs are structural. And what I mean by that is, if you look at the body of the car, the chassis, it relies on the battery pack to be part of the body to take some of the loads. Now, the difference between the 4680 cells and the 2170 cells is that the ones with the regular batteries, the cells themselves are not structural, which means you have to make the battery packs itself, you have to bolster it with the bars and so on. You have to make a stronger pack, which carries the batteries as a dead weight, as opposed to the structural 4680 pack, in which both the pack itself is structural and the cells also take some of the load. So the cells are also structural. So basically, if I look at the new cars, it'll be just like in Berlin and Austin right now. These packs will all be structural, but they can carry any kind of battery inside. I mean, they won't use pouch cells and so on, but any battery that they think will be good, they'll use it. They will mostly rely on LFP because the cars will be lighter, and especially the smaller cars, LFP will give good enough range. One thing else about LFP is also that the LFP, the chemistry itself, is getting better and better. It's currently just about on par with ternary chemistries of about 2 years ago and so on. So the LFP is very much better than people think. So Model Tau will be, I think, only LFP. Model Pi will be mostly LFP. As you can see, even right now, they're trying to sell Model 3 with LFP. They're pushing the Model 3 SR because they can get as many LFP cells as they want. It's really, they are not constrained with materials. And a good example is when CATL put up a factory in Shanghai next to Tesla's Gigafactory. They didn't build the factory from scratch. They purchased another factory. They purchased basically the buildings, so that they didn't have to build anything. But from empty buildings of another factory, it took them about 4 months, I think, until they produced 30 gigawatt hours per year at that rate. And they said that in less than a year, they would reach the full capacity of 70 gigawatt hours per year. So it only takes very few months to build such a factory of LFP batteries. And the only limiting factor here is the lithium, because the iron, the ferrite, you have a lot of it, and potassium also, they don't have any limitations of this. So it's really, they'll just make, most of the cars will just be LFPs. And what I mean by contingency is they don't rely on one thing. They will use 4680 cells as their preferred option, but anyone that can supply them with cells, enough cells, and cheap enough, they'll just go with it. They're doing it already. And okay. Now, one of the final things I want to discuss basically is the manufacturing revolutions. Sorry. Tesla's manufacturing revolutions. I see Tesla as having 3 manufacturing revolutions. But I'll finish, I think, with this slide. And after that, we'll just, if you have any questions and so on, I can answer them, and I'll go through the chat and see what I can discuss with you. So basically, Tesla had 3 manufacturing revolutions with the EV. The first one, I think I say, is humans are expensive. Let's use robots. And this is what they had this production hell, basically, in the beginning. When they started making Model 3, it was their first mass market car. They shoved in as many robots as possible. And there were things that didn't work so well. So they kept the humans, but still the car is made with more robots than is usual, as far as I know. So they have lots of robots. But the second manufacturing revolution was that robots are expensive and also unreliable. You have to maintain them and so on. So they are very reliable, but you have to maintain them and they have malfunctions and so on. So let's replace the robots with gigacastings. And as I said, the new cars will be just almost entirely gigacast. So we'll have the entire chassis will be gigacast. Not as one part, but it'll still be gigacast. Now, what I see coming with Model Pi and Tau, and be sooner than most people expect, and I know that Scott and probably also John Gibbs, Dr. Northall, they also expect this. They and I expect that the third revolution will be there are still too many humans in manufacturing. Let's replace them with Optimus. Now, my expectation will be, it's also based on things I discussed with my CDO friend a year ago and so on. I expect them to have Optimus working in the factory this year. And what I mean by working is not just learning and training. They already did that. And they're improving the Optimus. They are going through versions and so on and improving it on the fly. But the thing with agile manufacturing, agile work is that you go through iterations, fail fast and so on. So you make the first version of the Optimus, and as we saw before, that it worked it was still very cumbersome and so on. But you learn how the operations go and how they flow, and you change the robot a bit, and you go through another cycle and see how it performs in the factory next and so on. So what I see them is this year using Optimus relatively extensively, not in all stations, but in more than one station in the factory line. I do think that in Investors Day, they will at the very least, show it to those with NDAs, show Optimus working. I don't know if it will be in the public part, but at least those who are doing the factory tour and watching the production line that they will see, the most advanced production line, will not be for Model Y. It will be for the new Tesla Pi, and I think they will see a demonstration of Optimus at one station. But by the end of this year, I see Optimus performing in several stations, and maybe in a year or two, just about the entire factory will be with Optimus versions, several versions of Optimus, and this will be the alien dreadnought. That factory is just machines just spitting out cars, one after the other, and that's Elon's goal, and this is why it's heading this way. Why all these gigacastings, and they are willing, even if the materials and so on will cost more, but if it's faster to produce and uses less factory space, and it can be automated everything, then they will do it. And Optimus fits in, and I think by the end of this year, most of the factory will be with Optimus. By the end of next year, then they will have lots and lots and lots of these. By the way, Randy Kirk is also very optimistic about this. It's also, I think that we're very similar in our thoughts about Optimus and basically Tesla's future and Elon, the things he does. I think that's enough for this slideshow and so on. Other things are less important. Let's probably go to the chat and see what's going on there. If you have any questions, please just write question with large letters and just ask them. Yes, your Scott wrote about the brake-by-wire and steer-by-wire, making a fully modular skateboard. That's very true. They can make it large. They can make a larger skateboard for, let's say, if they want to make the Model S and Model X on it, or Cybertruck and so on. They can make it shorter for the Model Tau and so on. That's the side of the everything. The moment things are not connected, then everything is open. And by the way, this is not new. Basically, I'll tell you something that was very bugs me with the GM. In the year 2002, GM showed a car that basically it was an electric skateboard, very much like Tesla uses now. And that skateboard, they called it the GM autonomy concept. And later on, they made a show car based on it. They included the body and so on. And it was the GM Highwire. Maybe I'll make a video about them. And basically, these cars, they just showed how when everything is by wire, then everything, they had the skateboard, they just had connectors in which they plugged the wires that went to the steering wheel or to the brakes and so on. And if you wanted to have a left-hand drive car or right-hand drive car, you just moved the controls to the other side of the car. And it really simplifies things. It makes everything much, much cheaper and faster to produce. But then didn't just drop the ball. They decided they don't want it. They just wanted to stay with ICE and left it. And GM had great engineers at the time. And they just decided the engineers were great. The management was very bad. So they put the ball on the ground while they were leading and left the field, left the stadium. And GM could have been what Tesla is right now, but the management just destroyed it. And of course, Elon is not in GM. So that's how things changed. So that's by wire. Everything is much, much cheaper. When will Tesla implement solid-state batteries? So that's by Legendary Infotainment. He also entered it ASAP as soon as practical. And they're just open to all the, they're open for all possible battery types and so on. They're not blocking it, but the technology is just not there right now to produce them fast enough and cheaply enough. Do you think any Optimus deployed in factory already by Randy? Hi, Randy. As I said before, yes, I think they are deployed. Right now, it's still basically more learning how to tune Optimus and so on, how to build it, how to build a better version, but it's already working. Now, the nice thing about Tesla, there's one thing I didn't say before. One of the strategies I wanted to discuss was also a parallelization. When you talk about production lines, basically you think of it as a line. And that's how it was in factories all along the time. And the thing is with Tesla, what Joe Justice told us is that it's not a line, it's cells. you have production cells, 3D cells, so you can just go and do things in parallel. So what happens is if you, let's say Optimus can do the job right now, but it's still slower than what humans can do. A moment. Let's say what Optimus is doing is just fitting some kind of wire or inside the car, which means that they have to plug a connector on one side, thread the wire along some kind of route, and plug the connector on the other side. So what they need to do is just open a parallel station to where humans are doing this process. And in the beginning, Optimus will get one car and work on it, and it'll take it some time. And once it gets to the car, the car will go up the flow to the next station and continue, because the car checks itself and sees that everything is okay, and it passes the quality checks, so it can go on. And as Optimus gets better and better at the station, it will start and gets faster. It'll start getting more and more cars until eventually it starts getting all the cars, and humans will stop getting cars because Optimus will do things better. And then if you want to parallelize, you can put another Optimus. Now, I want to show you something. There's a bit after time, but if any people stay, if you are still staying, I'll show this. One moment. I want to show you something interesting about the gigacasting process. You see here that the robot arm is taking the casting out of the body. Here people are expecting something. No, it's not the best movie. Best video. Okay, I'll just wing it. I'll talk about it. Basically, okay, basically, when you look at, I'll post later on a link below to one of the gigacasting videos. But what you see in the video there is that you see that once the robot arm takes the casting out of the gigapress, it takes it out to quenching process, which means it puts it in a bath of liquid, and water or oil, to cool it quickly and harden it. And then it takes it to another station where it passes through, it goes through materials, excess material is taken off, and there's the holes are drilled for attachments and so on. And what you see in the process is that the same robot is doing the same part there and the same process. And Tesla is all the time, it's making the, I think this is the move video. Yeah. Yeah, here it is. No, sorry, I'll just talk. So basically what happens is the gigapress just, the same robot takes and does many, many processes, one after the other. I don't see this happening in the new car. The robot will just take the casting out of the gigapress, pass it through quenching, and pass it to another robot, and so on. or it'll go and continue. There will be moving parts and so on, because I think this will become bottleneck. Tesla is making the gigapress going faster and faster. When we saw this in several videos, when Jordan Gisicki, the Linux manufacturer, was in the Giga Audio, he talked with some Tesla employees near the gigapress, and he saw that there was a different cooling system on one of the gigapresses, and it was to enable it to work even faster than currently, and it's very, very fast. And also when Sandy Monroe had a visit in IDRA, they also told him about how Tesla wants to make things go even faster. So I think Tesla will make the gigapress work faster than now. And what this means is, if we look at the casting process, I wish I don't have the video here. I didn't plan on showing you this. But basically, when you look at the casting process, you see that the robot arm that takes the casting out of the press, it just takes it out, and then it just does things with the casting, instead of just handing it over and taking another part outside of the press. So basically, I think they will just streamline the process, so there will be less bottlenecks, and they think that part specifically will be a bottleneck because the gigapress will work much, much faster than currently. Okay. Let's stop the sharing and see what goes on with the questions. Okay. Did you have any questions? Okay, I see, Scott, thanks for the confirming this, that Scott confirmed that the robot can be a bottleneck there. Thanks. There are many of the processes, by the way. You see right now that because production is going very, very slow, then they can afford to have the same robot or same machine doing the same many processes. But what they'll do later on, they'll just streamline it so there will be less bottlenecks. And if there will be a station that does take too much time, because let's say there's a process that takes too much time, then either they break it down to different sub-processes, or another thing that is done in car factories right now, even in ICE cars and so on, they can let the station just continue with the line for a while. So the line progresses, but the station just progresses, let's say, double the length of that a regular station takes. So people just do things on the car, and then they return back to where they started. So they have more time to work on the car. But with Tesla, what they'll do, they'll also parallelize things by just opening. If some station takes too much time, they'll just open 2 cells to do that station, and each of them will get half of the cars, so they can do things at half the time, and it won't be a bottleneck as things currently are. Okay. Any other questions? If you have questions, please ask them with a large question before that. Didn't see any questions here. Okay, thank you, Lionheart, for being grateful to hear me. Okay, question by Scott. Scott M. By the way, Scott M is also my patron who gave me the idea for this entire series. He's the one that came up with Project Highland being related to Ford's Highland Park. Okay, as Tesla continues to vertically integrate, will they go as far as innovating in the materials mining industry? Will they utilize their boring company, MVs, to do so? Thanks. Oh, That's a good one. I'm no expert in mining, first of all. I think that mining, the main problem with that is Jordan Kissinger, the limiting factor, discussed it very extensively. There are lots of political issues with mining, which Tesla wouldn't want to normally touch. Their preferred solution will be to work with other companies. In case other companies can't work fast enough, then I do think Tesla will help them either with machinery or they will buy them. I think that the Boring company has extensive knowledge that they can use. It's not identical to what's done with mining right now. There are things that are different with mines relative to just digging the tunnels, but there are also very things that are similar, and I think that Tesla will, at the very least, provide electric mining equipment, and I think they'll do, they can help with that. Question by Ken1, why do I protect my identity? That's a good one. Several reasons. One of them is basically I protect it online in other, even not here. I don't have a Facebook account, for example. When I did, I didn't have my picture and so on. But basically, a lot of my work has been, some of it, but a lot of it was within the defense sector. And it's fine doing things in social platforms and so on while working there. But because I'm open to confidential products and so on, I have to inform them that I'm doing this so that they can check if they want to, that I'm not disclosing any secrets and so on, anything confidential, which I'm not. I'm not discussing anything about my work. And when the few times that I did so without giving anything from confidential projects and so on. But what will happen if I tell them that I'm doing that, then I won't feel free to discuss my investments, for example, and so on. It's not a problem with them, but I don't want people that I work with or people that know me to know that. So I prefer to protect my identity, and that's it. Sorry about that. It's really a hassle for me as well. This whole streaming going through Zoom was just because it's what helped me do that, and I have to find a better solution right now. Okay. A question by Sonic Liberation. Can you imagine gross margin going to the... can you imagine GM going to the UAW and saying we want to use the Optimus? That's a very good one. I like that. But by the way, yes. And the main reason is that if you look at GM, they are one of the most productive companies. If you compare them productivity per, one moment, productivity per person, they are one of the largest, and per employee. And the reason is, first of all, they don't count the employees in China. Each car produced in China in their joint ventures, they count it as a GM car, but they don't count the employees that work there, only employees in the USA. But if you look at US employees, the funny thing is they don't have a lot of employees because their employees are mostly UAW, and the ones that they hire are mostly not UAW. And the reason I see is that UAW is a large shareholder of GM. And there was a time that they were the largest private shareholder. I don't know what about it now. So what happens is when they get part of GM's profits, and if GM can replace all the non-UAW workers with Optimus, and by that get higher results, what will happen is they'll just, it'll be better profits for them, and the workers, the UAW employees, will get more money from that. UAW employees in GM and the UAW itself, the union, will get profits from GM. So there's no problem for them to replace non-unionized workers by robots. Okay, Scott Kirkwood, what about robotaxi in boring company tunnels? I do see robotaxi working in going through boring company tunnels. I see, if we go far into the future, that Tesla will have an entire ecosystem that the cars will connect to, and they will be robot. First of all, you will have some kind of controller, not a smartphone. I don't think they'll go into smartphones, but even before getting to Neuralink, which will take time, there will be, first there were computers, large computers, then there were PCs, home computers, and laptops, and then there came the iPhone and so on, the smartphones. And there are too many years right now of that technology advanced, but we're still using the same old thing that Steve Jobs showed many, many years ago on the smartphones. So there should be by now, very soon, something, the next generation, something that will replace the smartphone. And I think once that comes out, whether Tesla invents it or it's just can enter early into the realm, they will use it and they will make a controller that will control their entire ecosystem, which will be the home HVAC and smart home and the Tesla cars, and you can order a robotaxi and you can arrange the to go through boring tunnels, and you can go to you can book an intercontinental flight with SpaceX and so on, using the Tesla ecosystem and so on. So yes, see that coming. Randy Kirk, do you think any Optimus deployed in factory already? I answered that already, sorry. Boring company will become a mining company, I answered that. Why aren't you doing this on Twitter Spaces by Dusty Green? You are 100% correct. I just, I'll do this in the future. I didn't do it. It's just, I wanted to do it as fast as possible. I came up with the idea yesterday and just went to, I came up with the idea yesterday, but I didn't have time to prepare. So I did what I knew will be fast. Question, will Tesla use sodium ion? Great question by H. Timmermans. Yes, they will. 3 reasons for that. One of them is basically they're open to any chemistry. And once sodium ion can be made in large quantities and it'll be cheaper, then yes, they will use it, especially in the cheaper cars and so on, lower range cars and so on. So they will use it. But also another reason is that we heard Jeff Dunn discuss it recently. And the third reason is that what he discussed was also that sodium ion, and we don't have enough lithium, and sodium is much easier to obtain. So at least for storage, it's a no-brainer. Once they can make it in scale, they will. They can make 4680s or whatever. Using robots will be multi-year FSD delay all over again. I don't think so. Curious Sense said that robots will delay FSD. The people working on that should be different people. Question by Martin Nielsen. In what ways can Optimus bots be better on the production line than traditional robot arms moving on rails? Basically, because what Tesla can do with robot arms, they do, and they are doing it right now. but they still have human workers. And the idea with Tesla bot, with Optimus, is just to replace the humans, with just replacing humans in the factory. Chris van der Meulen, Tesla will use any cylindrical or blade battery with good chemical composition. Yes, that's true. I believe so. I'm sorry, I don't know how to pronounce it. MXUX question: would Tesla ever use hub motors to simplify the drivetrain? Would eliminate hundreds of parts. Why haven't they? I'm not a fan of hub motors. They have a lot of inertia. They can use it. I don't think they're reliable enough. What we saw with, for example, with workers or Lordstown motors, they did show hub motors, but they were from some kind of e-bike or whatever. They really aren't reliable enough. The rotating area, the motor itself is just, I don't believe in it, let's say. And also it's on lighter cars, it won't be any good. It's also because it's the heavy motor is in the unsprung area. It's in the hub itself. And in Teslas, it's in the middle, it's in the sprung area. So it behaves better. For smaller cars, it's easier. Oh no, Northley. Silly question, but will the cars being wireless interfere with each other the way Wi-Fi router frequencies can collide? Good question, but no, it's very, there are protocols to ensure that there won't be any interference. And with cars, everything is redundant and it will be foolproof. There won't be any problem with that. Rolf Kocher, glad to see you here, Rolf. Will you keep your focus on Tesla, or is sustainable food a possible topic for Mars and Tesla restaurants as well? That's an interesting question. My main focus, let's say I came to this channel to talk about Tesla because I want to talk about the future, something that really interested me. My main focus will be on Tesla, but I will deal with other projects. And yes, I think I will discuss sustainable food. Someone sent me some time ago about vertical food farms and so on, something really interesting. The technologies are breathtaking. I think I will do something about that. If so, I will let you know. How is my programmer friend's business? Oh, great question. There are things I'm allowed to talk about her, and there are things I'm not. Sorry about. I can't discuss current situation. Sorry, I can't discuss this one. Let me know if you want me to make some video about her. Really interesting person. I have a lot of things to say about how I met her. And things she did and so on. I describe her all the time as the best lemonade maker I know, because she'll take any lemon and make lemonade out of it. She got funding while there was a big epidemic and the markets crashed. At that time, she got funded and so on. So she really knows how to make, and she used the fear to get funded. So basically, she's brilliant. So let me know if you want me to do anything about her personally, but I can't discuss her business right now. If you have questions, please write question before. Okay, question by Scott M. How about casting 4 wheels at once? I don't know how much of that will be better to cast the wheels separately, because they have to be connected to the car. So I don't know how fast they could produce them. question by Legendary Infotainment. Would you happen to know if the factory AI is implemented across Tesla companies? It would seem reasonable and useful. I think it is. Yes. The factory AI, their CRM system, I think it's common to all factories, but I don't know. That's my guess, though. Let me know if you want me to make a video about that system, because I've heard some very interesting things about it, so let me know. Why can't we get rid of the 12-volt battery? The system is antiquated. I don't know about that. I think some of it is regulations, and some of it is that they are using right now the auxiliary equipment is just off-the-shelf equipment that use 12 volts. It's cheaper right now and more proficient. So they'll just use that. But they moved to lithium, by the way, to lithium 12-volt battery, which is better. My car has that. Cybertruck production later this year or next year or this year. That's my bet, but I don't know, but I bet this year. Charles 61, somebody says it's foolproof. I get nervous. It is. Things really are, when you're talking about safety systems, the way they are written, I did some projects that were safety critical, and you have no idea to what extent we went in designing our part of the system just so it wouldn't have to be considered safety critical, because you have to write the code itself in the way you have to write it is different. The path as you go is different. Everything is redundant. So it's really, that thing really is, let's say, I won't say it's 100% foolproof, but it is safer. But brake-by-wire is safer, more reliable than hydraulic brakes, which do have malfunctions. The hoses can be rupture or get burst and so on. The brake fluid can overheat and so on. Brake-by-wire is safer than hydraulic brakes. Steer-by-wire is safer than regular steering and so on. So that's better. Okay. I think we'll wrap it up right now. I'll just answer this last question here by Mark Webb. Don't wireless components in any case require a power wire? If they require it, why not pass communications through the power wire? And yeah, they will use power and communications on the same wires. No problem with that. And Marquette Greener question, having watched Tony Seba's videos on disruption, it seems given the things he says Elon has watched his videos. Do you think once Optimus is working, Tesla will move into precision fermentation? I don't know. I don't know about precision fermentation, if they will do it. I don't think Tesla will do that. Maybe other companies that Elon will spawn. I know that Kimball was into some things like that, but I don't think Tesla will do that. It's another kind of company. Gave me an idea. I think I'll make a video soon about Tesla's greatest asset that people don't know about, their greatest multiplier that other companies don't have. I'll talk about it in a future video. So right now, I think we had enough. It was an hour and a half. So thank you very much, guys. I really enjoyed this. I promise next time I'll do it without all these glitches and so on. It'll be better. And thank you for remaining with me this long. I'm glad to have you. Bye, guys.